Hey, today we're going to be talking about reflection, refraction, and diffraction, amongst a few other things. But specifically today, you're going to learn about the definition of reflection, refraction, and diffraction, the definition of interference, how superposition relates to constructive and destructive interference, how to identify a node and an antinode in a standing wave. Well, reflection. What is reflection? Reflection is the bouncing of a wave off of a surface. So, when you have a mirror, for example, and you have the light that reflects off, and you can see yourself, or if up on the wall now, you bounce the light off, and you see where the light beam, or a laser beam. Quite often here, you'll bounce a laser beam off the desk, and you'll see it up against the wall. That is reflection because it is bouncing. Reflection is the bouncing of a wave off a surface. An echo is a reflection. All right, that's important for us to know. Refraction. Refraction is the bending of a wave as it goes from one medium to another. Examples of that would be, let's say we have a glass. Let's make ourselves a glass. We've got this glass, and in this glass we've got this water. It's full of water. Right? So we've got this glass of water, and we've got this beam that's going to go into it. Well, what typically happens then is the beam is bent. All right, it's going to come off at a different angle in these cases. This is refraction. Likewise, a very similar thing happens. Let's say we've got concrete here, and then off to the side of the concrete, we've got grass that's growing. And we're going to take a lawnmower, and we're going to take this lawnmower, and we're pushing it on here. Well, on the lawnmower here, we've got, the motor, and you've got the wheels on the sides here. Well, what I want you to understand is this is also an example of refraction, because what happens now is, let's add a little bit more here to the motor. There we go. Okay, what happens with our lawnmower is we're going at a certain speed, and because the front tire goes into the grass and it's not able to move as fast as it was moving, your lawnmower is going to change direction. It's going to bend into, or actually turn away from, it's going to bend towards the perpendicular, because the rest of the lawnmower is able to travel faster than the part of the lawnmower that's in the grass. It's going to move slower because of the friction, and it changes direction. So that's also an example of what refraction somewhat does. We'll go into a little bit more direct definition later, but I want you to understand that refraction is the bending. Diffraction. All right. Diffraction is a good example of diffraction is, let's say I've got, here is the corner of a door, and here. So I'm looking at a door from the top, or a window or whatever. We've got this door here, and the door is completely open. So here's the door. And someone is shoots a beam of light. Well, what happens here with this is the light will actually bend. All right. The light will start to make a bend around here, and it starts to open. What that is then is this is diffraction. Notice the width of the beam of light is wider here than what it was here, and this right here is the diffraction process here. It's bending, but it's also going to start to open up, and the actual bending part is right here. It will start to bend around a corner, and you'll see that with waves. Let's say on a lake. All right, if we had water waves that are coming by, and then pretty soon you have a rock, all right, something that's sticking out of the water. Well, what eventually happens is, obviously there's a break in the waves, but at some point the waves come back together again. And that is the diffraction, this process here where the waves are bending around this obstacle. They're coming back together here. That is diffraction. Okay, some other things we want to talk about today is interference. All interference has a general name called superposition. And superposition is when two waves are going to overlap each other. And I'm going to draw some examples of this here for us. Interference pattern is when superposition has parts that amplify or cancel. So let's talk about this superposition and when the waves are on top of each other, and then specifically the interference patterns that result from the superposition. In constructive interference, we have superposition because we have two waves that are traveling at each other. And what I want you to see is when they superimpose, when they have superposition, when they're on top of each other, the interference pattern, when these two are on top of each other, you're going to have the first wave. Alright, so this right here we'll say had an amplitude of 3. And let's say this has an amplitude of 4. Well, the interference pattern now is going to be both of them built on top of each other. For the split second that they are overlapping each other, when we have this superposition, we have what's called constructive interference. And that means that we have an amplitude that creates a larger displacement. The amplitude here now is 7. It's larger than each of them individually because they're being added together. The next split second, these two waves now would be continuing to move on their own way. And we no longer have superposition because the two waves are no longer on top of each other at that point. Alright, the next example. Destructive interference. Well, here's a good example of destructive interference. I've got a wave coming this way. And let's say it has an amplitude of 5. And I've got a wave now coming this way with an amplitude of 2. Well, destructive interference would be when these two waves superimpose, or the superposition on top of each other. So I'm going to draw it up here at the top. I'd have one wave up here on top with 5. I'd have another wave on bottom with an amplitude of -2. Actually, I probably should put there. So what is the resultant? The resultant is the -2 and the 5 are going to somewhat cancel each other. And I'm going to end up with a new wave that has an amplitude of 3. Again, just a moment later, these waves would continue. And I'd have my wave with amplitude 5 going to the right and my amplitude of -2 going to the left. Alright, our last thing here. Standing waves. Alright, examples of a standing wave. Well, we're going to talk about this with a large spring, and we haven't done it yesterday. We're going to do it today. And I'm going to take a spring, and we're going to get this long wave here. And a standing wave is a wave that appears to have both a crest and a trough. Along here. The wave would be going back and forth, and it appears to be just standing or sitting there in place. It's going so fast that all we see is the top and the bottom, and in between we don't really see anything. The nodes, right? Location where two waves meet with destructive interference. So right here and right here are what we call nodes. And right here is a node, and right here is a node. This is where there's destructive interference, meaning that we have the least amount of amplitude. Alright, if you notice, that's where there's no amplitude. Nodes for no amplitude is how I always remember it. Antinodes, location where two waves meet with constructive interference. Where are we going to have the most interference? Well, that means, do this here, right here and here is an antinode. Here and here, an antinode. Antinode. So that is examples of a standing wave here, and we're going to show that in class. And we have our nodes and antinodes. Well, hey, I hope this has been beneficial for you. I'll see you on the flip side.